Alright, boys and girls, welcome to our second video lesson. Our lesson on solving systems. This will be our two algebraic methods, substitution and elimination. Okay, so there are three methods that you know well to solving systems. There's a good half dozen, if not more, methods to solving systems. We did graphing yesterday. That's just where we're going to graph the two equations and find their point of intersection. And then there's the two algebraic methods, substitution, which we'll do first, and then elimination. And all this stuff you guys learned way back in Algebra 1. So let's look at the steps to solving a system by substitution. Step 1, first thing you're going to do is solve one of the equations for one of the variables. Again, look and be smart. Choose the easiest equation and variable to solve for. Plug that expression, once we solve the expression for the one variable, into the other equation. Solve that equation in one variable. And once we get our answer, either x equals or y equals, we're going to plug that back into the first equation to get our second coordinate in our ordered pair. Let's do one. So we have x minus 2y is equal to negative 5, and we have y equals x plus 2. This second equation is already solved for one of the variables. So what I'm going to do now is I'm going to take this y, it equals x plus 2, and I'm going to plug it in right here. Okay, so I take this y, x plus 2, and I plug it in right here. So I'm going to have now x minus 2y, but y is also x plus 2, and that equals negative 5. I'm going to solve this equation for x now, so I get x. I'm going to distribute my negative 2, negative 2x. Negative 2 times 2 is negative 4, and that's equal to negative 5. X minus 2x, I'm going to combine my like terms. X minus 2x is negative x minus 4 is equal to negative 5. Add the 4 to both sides. It looks like negative x is equal to negative 1. So I divide both sides by negative 1. X is going to equal positive 1. Once I have that, let's plug that back into either one of my two equations. It's probably easier to do it in this one right here. So I take that x, let it be 1, so I have y equals x, which is 1 plus 2. Y equals 3. So my ordered pair, my solution now is going to be x equals 1, y equals 3. So I have the ordered pair 1, 3. Looking at this guy right here, we want to solve one of these equations for either x or y. It probably doesn't matter. Let's just take the first one and let's solve that for x. So I'm going to add the 2y to both sides. So I'm going to get x is equal to 2y plus 3. I'm now going to take that and I'm going to plug it in. I'm going to take this x right here, which is 2y plus 3, and plug it in right there. So I have 2 times x, which is 2y plus 3, plus y, that's this guy right here, is equal to 11. I'm going to distribute. 2 times 2y is 4y. 2 times 3 is 6, plus y is equal to 11. It looks like I now have 5y when I combine like terms. Plus 6 is equal to 11. I'm going to subtract 6 from both sides. I get 5y is equal to 5. So therefore divide by 5, divide by 5. Y is equal to 1. Once I have y is equal to 1, probably the easiest thing to do is plug that back in right here. It's the easiest equation to do that. So I have x is equal to 2 times y, which is 1, plus 3. X is equal to 2 times 1 is 2 plus 3 is 5. So therefore my ordered pair, do that in purple so it's different. My ordered pair is 5, 1. Okay, the steps to solving a system by elimination is put both equations in standard form. which is ax plus by is equal to c, or both equations in slope-intercept form. And that is when we want to line up our variables. We want to line up our x's with our x's and our y's with our y's. Multiply one or both of the equations so that one of the variables' coefficients are the same. We're going to add or subtract the equations right the way they are. That will thus eliminate one of the variables. Solve that new equation in one variable. And then again, last step is to plug that solution into the other, or to another equation, let's just say another equation, to solve for the other variable. Let's try one. So I have x plus 3y is equal to 13, and I have 3x minus 2y is equal to neg 27. If I'm looking here, I can multiply the first equation by negative 3. Whoop, I need to turn my marker on. By negative 3. By doing that, my x's are going to have the same coefficient, 3 and neg 3. So negative 3 times x is neg 3x. Negative 3 times 3y is neg 9y. And negative 3 times 13 is negative 39. I'm now going to add these right the way they are. 3x plus negative 3x is 0x. Negative 2y minus 9y is negative 11y. And negative 27 minus 39 is negative 66. Divide both sides by neg 11. You get y is equal to 6. Once we have y is equal to 6, let's plug that back in. We can do it to either equation. It doesn't really matter. I'm just going to, for the fun of it, choose this one. So I have x plus 3y, and y is 6, equals 13. So I have x plus 18 is equal to 13. Subtract the 18 from both sides. It looks like x is equal to neg 5. So therefore, my ordered pair, we'll do that in blue, is x is negative 5, y is 6. So I have the ordered pair neg 5, comma, pos 6. Looking at this one right here, we need to line up our variables so they already are. Notice that the y's both have the same coefficient. What I'm going to do, just quite simply, because I like to add, I'm going to multiply this by neg 1. So I get neg 4x plus y is equal to neg 26. I'm now going to add those right the way they are. 3x minus 4x is negative x. The y's will cancel, neg y plus y. And 19 minus 26 is neg 7. Divide both sides by neg 1. X is 7. If x is 7, let's plug that back in. We'll plug it back into the first one since that's what we have. So I have 4 times x, which is 7, minus y is equal to 26. 4 times 7 is 28, minus y is equal to 26. Subtract the 28 from both sides. I get neg y is equal to neg 2. Therefore, y is equal to 2. Let's switch colors to purple. My ordered pair is x is 7, so 7 comma y is 2. 7 comma 2. There we go. Let's try one more. This time, I have 4x minus 3y is equal to 11, and I have 3x minus 5y is equal to 11. I need to eliminate either my x's or y's, so I need to get the coefficients the same. Just for the fun of it, let's get rid of our x's. So what I need to do is I need to make this coefficient the same as this one. So the little trick is I'm going to multiply the top equation by 3, and I do that because that's this coefficient right there. And I'm going to multiply the bottom equation by neg 4, and I choose neg 4, so I get a negative 12x with the positive 12x. So now I'm going to distribute. 3 times 4x is 12x. 3 times negative 3y is negative 9y. 3 times 11 is 33. Negative 4 times 3x is neg 12x. Negative 4 times negative 5y is positive 20y. And negative 4 times 11 is negative 44. So it looks like now, when I add these up right the way they are, my x's go away. 12x minus 12x is 0. I get neg 9y plus 20y is 11y. I just get rid of my 0. and that's equal to 33 minus 44, which is negative 11. Divide by 11 on both sides. Y is equal to neg 1. I'm going to take that and I'm going to plug it back into one of my original equations. It really doesn't matter. Let's just choose the second one this time for the fun of it. And this is fun. So I'm going to do 3x minus 5 times y, but y is neg 1, is equal to 11. I have 3x minus 5 times negative 1 is positive 5, is equal to 11. Subtract the 5. I get 3x is equal to 6, divided by 3 on both sides. X is equal to 2. So therefore now my ordered pair is x equals 2 and y equals neg 1. My ordered pair is 2 comma neg 1. Alrighty. Easy as pie. We'll see you soon.